Hi everyone, my name is Laura, and today I'll be going over the successful attributes of a design system, including its implementation, its adoption throughout an organization, so all the things that make a developer swipe right on a design system. And swipe right is the good one, it's the one that we want. So like I said, my name is Laura. I got my Bachelor of Design in Toronto at OCAD University, and then I attended the bootcamp formerly known as HackerU for 10 weeks, doing their front-end web development program. And shortly afterwards, I started working at SurveyMonkey, and I've been here for 3 years as a front-end engineer on the Wufoo team, which was acquired in 2011. Don't quote me on that. As you can see, I am into llamas, I'm into cats, I'm told I have dog person energy, so that's fine. So who's this talk for? Primarily it's for the organizations who already have buy-in for a design system or already have one in place, and they want to ensure that the design system is usable, readable, understandable, and upholds the values of the company. It's for the people who are going to be consuming or trusting the design system in their production code. So it's mostly aimed at developers, but there are some general good practices sprinkled in there as well. So this was essentially me on my team when I started right after brand refresh. We were in that sweet spot where there was already a business need for a single source of truth. The company realized that they were re-architecting the core platform from being a monolithic application to a series of vertical microservices. So there would be a team in charge of payments, a team in charge of authorization, a team in charge of the survey creation experience, and so on. In addition to that, they had acquired a number of companies in recent years, such as Ottawa-born Fluidware would become SurveyMonkey Apply, the team I'm on, Wufoo. And the company recognized that with such a separation of concerns, they would need to enforce some sort of consistency in the UI. Having every single button hard-coded with different padding or font size just wouldn't cut it for an enterprise product. So they built a small team with a handful of designers and developers and created the first components of what would become the Wrench Design System, or WDS as we call it. And my team would be one of the first products to consume this design system. Prior to us, it had never been used in production. We were a small enough team of engineers going through our own rebrand, so it would make the perfect first pass at implementation. And this is what we were looking for in the design system. The biggest goal for us was that it needed to be more convenient for an engineer to use the design system component than to build one on their own from scratch. So to do that, to accomplish that, the design system ideally should be accessible, it should be tested, it should be fairly easy for me to adopt, jump in and start using it. It should be customizable and extensible in the ways that I need it to be, and it should be immune to trends. So that's why we built it in React. We're not immune to trends. In all honesty, we have 600 engineers building out our products. So once we made a decision to use something like React, which we did for the entire company, we committed to that for the foreseeable long term. But we did build it in such a way that our CSS does a fair amount of the heavy lifting, which makes it fairly tech agnostic, but I'll get to that in a bit. So accessibility. First off, I want to talk about this because it's not optional, it's not negotiable. How can an engineer build an accessible house if the bricks themselves are not accessible? It's a bad metaphor, whatever, you get the idea. Things like color contrast, font size, hover states, other visual tokens, they're usually taken into account at the design stage, but it goes without saying that things like semantic HTML, tab indexes, image alt tags, unique ID values, those are the responsibility of the developer, in addition to the implementation of the visual cues we just talked about. It falls on the design system to provide a base on which developers can build accessible products, right? So as an example, if we wanted to implement one of these type ahead select dropdowns, one that filters through the options as the user types, there are a few ways this can be achieved. Initially, something like this functions, it serves our purposes, but a screen reader will lose focus on this on the input as soon as it navigates through the options because the text input and the menu are two separate items. To fix this, we can do something woke, like create one component that handles both functions. This way, the select component connects the input with the associated list of options. Of course, this is just pseudocode. The real example looks something like this. I stole this from Slack, from their type ahead component. It's using JavaScript utilities to build and connect the IDs that are informing all those area attributes. So as you can see, it's quite technical in practice, and having this baked into each one of the components means the developer doesn't have to do that. It just comes free. The adopters of the design system are responsible for the configuration of each element, such as the roles, the ARIA labels, the checkbox attributes, but the design system documentation should detail the easiest way to customize each of those values. People need to be able to understand it in order to use it. So it should almost feel like a checklist. In addition to those implementation details on each component, I'd encourage the design system documentation to house more generic accessibility guidelines, maybe a more digestible introduction to WK content in order to encourage a broader understanding and proper uses. The WK content is great and very detailed, but not all of it is relevant to every single application. So having WK as it pertains to your company or your organization would be fantastic. As part of the testing strategy, the design system can throw errors if a property is missed, if something is blatantly going against WK guidelines. Maybe you're missing a hidden label on a checkbox, or maybe you have a form that there should be instructions that mandate a descriptive header for each form. There should be dependent criteria related to the context of that component. There are also loads of tools for doing a quick accessibility audit. They'll run through any given web page. They'll return errors in varying severity of what's wrong in the web page, from color contrast to broken tab indexes, you name it, semantic HTML, so on. At the end of the day, making each component accessible doesn't guarantee that the entire experience is accessible. Since the design system only controls those atomic components, accessibility is concerned with the entire web app or application flow. But at least you're providing engineers with those accessible bricks. Still a bad metaphor, I'm sorry. Testing. Design systems, they're a single point of failure for front-end teams. In essence, design systems are a dependency. If you change a design system component, that change propagates to all the dependent apps. The mechanism for distributing those changes is unbiased. It'll ship improvements and it'll ship bugs. To mitigate that, it's important to implement relevant testing strategies. And I say relevant because there is such a thing as testing bloat. Since design systems are UI components, it makes sense to test them visually. We can use visual regression tests with different permutations, such as different props and variants such as browsers and devices. There are tools that handle this. I think Chromatic, that'll take a screenshot of your component in production and compare it to the changed screenshots and notify you of those changes, and then you can review them and make sure that those are intentional. And you can set this up with your continuous integration flow to make sure that it always runs and checks anytime the code is changed. Unit tests, gotta love them. They'll check that the component returns a specific output given a certain input. It's great for something that's kind of functionally intricate, like a date picker. It can be tough to just test something like that visually. If there are multiple contributors to the design system, linters, great. We love a good linter in order to make sure that all of the testing, the code follows the same rules and tests for any sort of linting errors. And as I spoke about before, this is a great place to consider an accessibility audit. Here's a quick example of a unit test for a link component. As you can see in the first expect statement down at the bottom there, it's checking that the link href attribute isn't null. You have no idea what the link is where it's gonna go, but you can check that it's not empty and that the text content of the link is correct. But Laura, what about functional tests or end-to-end tests or Selenium, manual tests? Yes, there are lots of options out there in order to check the hardened versions of these components. But something like Selenium or end-to-end tests tend to be kind of overkill. They traverse the DOM during a series of actions like a login or a checkout. It's tough to create and maintain tests for those very specific flows when you've just built this single component. Manual testing is also tough to do at the design system level since it's up to how the components are working within the greater project, which is where a QA engineer or an SDET would be valuable when testing the entire overall flow of that component. As the system gets more complex and starts thinking about things like dark mode or localization for languages that read right to left, for example, the testing scenarios also get more complex. So it's important to avoid that testing bloat and just test the atomic components. Adoptability or learnability. The overall goal of the design system should be that adopting it is easier, more efficient, and produces a better result than building that component manually yourself. The team has to trust the system will reduce time and reduce risk. The goal that getting users onboarded should be fairly painless and hopefully empowering, and that when they hit roadblocks, they feel confident that they can find the answers through the documentation. So first, checking the installation process It should be clear. A simple yarn install or npm start is great. If the developer gets blocked by their environment or has issues, hopefully there is additional documentation or someone that they can reach out to. It's also ideal to have things like how the assets are consumed, or if there are various frameworks to choose from and that sort of thing somewhere in the documentation. Next, they should be able to implement overall visual styles like fonts, primary colors, CSS mix-ins, secondary colors, things that they can use throughout the entire project. Then comes the fun part, the components. This should encapsulate how a component is imported or accessed, how the component is configured by adjusting the props or the class names, extending the component. They should be able to use lower order system features like design tokens, and use all of these pieces to build more complex components like a card item. And lastly, it's important to document any theming or additional flexibility that the engineer might not know about at first pass. Also I've tossed this in, something like having the structure of your file system can really help an adopter or a contributor just get up and go, get started and get running and know exactly where they need to find things. And of course, ideally the design system team is available and approachable on Slack, or they have office hours to encourage adopters to ask questions or make suggestions. By sticking to the most basic components, we avoid the need for a user to come in and read the documentation front to back. I should be able to come in, import the library, and toss an icon into the UI without too much prior knowledge. Customizability or extensibility is important. Design systems at their core are pure presentational. The components deal with how the UI appears. They respond exclusively to props. They're agnostic to how the data loads. They don't contain any app-specific business logic. So the first thing that we're looking for when building out our application is the easy wins. Which components in our product can we easily replace with the most basic, simple design components available? These are called atomic components. They're the building block of a design system. They're the core pieces, the buttons, inputs, icons, badges that are combined and made into more complex components. So this analogy that I'm showing here, it's coined by Brad Frost. It kind of continues to scale upwards into molecules, which are combinations of those atomic components, for example, like an input with a submit button. And even higher level, you get organisms, which are a combination of molecules that form an entire section of an interface. And they continue to go on, but I don't know chemistry, so that's where we're stopping. The goal with the atomic components is coverage. You want quick and easy implementation, and most importantly, non-breaking changes. The adopters can use them to build bigger molecules like a full contact card. If the design system provides that card, it introduces a ton of potential technical debt when a team needs to customize it. They may start overriding aspects of that card component. Instead, building it out in the atomic level components allows you for that flexibility. Try to omit one-offs that aren't currently being reused. Even if you hope they become part of the design system someday, a nimble team will avoid maintaining that excess code whenever possible. Flexible components. We can make sure that our components are flexible by adding the following. Variants, which are different versions of the component, maybe different color schemes. States, which show what happens when you interact with a component. Modifier, which is a different change that you can apply to a component by adding CSS class or perhaps by passing it different props. And dependencies. When we think about the item that design systems depend on the most, usually our minds go to icons. These tiny things, they're everywhere, and they need to be stable. For example, at SurveyMonkey early on in our design system days, we were using a specific font that housed all of our icons. So you'd type capital P in this font and it would be a pen, or you'd type the @ sign and it would be an envelope, so on, so forth. This obviously wasn't extensible, wasn't scalable, and we ended up building an icon library as its own package within the design system. This allowed us to scale it and stabilize our icons. So if I have a component like a tooltip, which in addition to its styling has maybe the collision detection around the edges of the viewport, perhaps it's got a trigger to toggle when it's open or closed state, as well as position or a z-index kind of in space, a layer. That means this tooltip has a dependency of each of those tokens, as do the other layered components with their own z-indexes. Looking at this dependency chain helps determine where the breaking changes would be, and it'll inform releases and tooling choices. and design tokens. I've mentioned this a few times, but when it comes to styling a design system, many of us are familiar with Sass variables or mixins used in some capacity like this. This is a pill component with all these CSS properties, and the values are things like background color light, border hairline, which would link back to a default Sass value, like a hex code or something in a separate file. This works fine in practice, but the default files tend to be contained in a web-based repo maintained by developers in a Sass file that may need to be imported numerous times in numerous products. And heaven forbid you change the name of border hairline there, and you need to update all of its instances. Instead, design tokens operate as a spec that is accessible to anyone in product, design, engineering. So instead of storing these values in a Sass file, we store them in an open format like JSON. At that point, you can transform those key value pairs to CSS properties and send them to Sass or Stylus or a sketch library, or the token data can be spread to iOS or converted to XML for Android. And the nice thing is that this is a very readable format. So designers, product folks can go in and see pretty clearly which each of these values is referring to, and can go in and change those and have those changes propagated to the entire design system. Going a step further, we can manage that token data using YAML. Since it supports commenting, it can be a little bit more readable to non-engineers. Then take the YAML file, transpile it to JSON, and then yeet it into the preprocessor of your choice. So again, here are those considerations. You want to build atomic, super small scale components. You want to make them as flexible as possible. You want to make sure that they respect their dependencies, and try to leverage more agnostic practices like design tokens. This flows nicely into the last consideration that I've put together today, which is the idea of interoperability, or making the entire design system as tech agnostic as possible. So the idea here is to avoid coupling your design system with a particular tech stack. Brad Frost also kind of coined this idea of decentralizing the HTML, the CSS, and the presentational JavaScript from the rest of the design system. Since those are the core languages of the front end, the idea is to pull them out and you get this canonical design system that is then transformed or compiled into different frameworks or languages. Each application or service consumes whatever the flavor of the design system is as a dependency. So for React apps, this means transforming the design system into JSX. For Angular, it would be directives. For Ruby, it's Sinatra. We also make use of design system tokens so that most of the styling is taken care of autonomously. A way to do that would be organizing your components in a standard way, maybe using manifest files to give the components metadata, which defines their dependencies and data types. You can then programmatically use tooling to transform those components into any number of intermediate formats, or the application can consume them directly. But of course, this tiered model requires a lot of foresight in order to be implemented from the jump, or it requires extra tooling to do the parsing and regurgitating for you. It's not too late. So that's pretty much all I have for you. I'll go over a quick recap of the topics that I covered. So for design systems, they should be looking at accessibility, testability, adoptability, customizability, and future-proofability. That will have you well on your way to a happy product. And you know what they say, happy PM, happy life. Sorry. And yeah, you heard it here, folks. Anyway, these tips should help you match with the hot single design systems in your area. I'll be available on Slack, or you can find me on the tweet machine at Laura Duggan. Thank you so much.